In this video, we are going to talk about what is the discriminant. Now, this is a good video to watch after you've watched the video on the quadratic formula. If you already know about the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, then you're ready to learn about the discriminant. The discriminant is the inside part of the radical in the quadratic formula. It is just the b squared minus 4ac. Now, if the directions of the question you're working on ask you to find the discriminant, do not take the square root. It is by far the most common mistake the students make, which is to take the square root. You don't. The discriminant is just this inside part of the radical. What is so important about this b squared minus 4ac? Well, the discriminant is there to tell us what's called the nature of the solutions. The nature of the solutions means that by just knowing the discriminant, we know how many solutions we're going to have, so the number of solutions, and we're also going to know the types of solutions that we're going to have. So on your screen, you have a chart, and the chart delineates what is going to happen depending on the value of the discriminant that you get. So if the discriminant is equal to 0, think about it. In the quadratic formula, that means that all of this is just going to become 0. When you get your answer and you do plus 0 or minus 0, you're going to be left with the same exact answer. When the discriminant is equal to 0, that means that you're going to have exactly one real solution. That solution is rational. Rational meaning it can be written as a fraction. Whole numbers can be written as fractions if you write them over 1. 1/2, 3/4, 5, -7, all of those are rational solutions. If the discriminant is equal to 0, then you're going to end up with one real rational root, which we call a double root. If instead the discriminant is equal to a number that is positive, and that number that is positive is a perfect square. What are perfect squares? 1 is a perfect square, 4, 9, 16, 25, 36, 49, etc. Okay? Because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. If when you do the discriminant, you get one of these perfect square positive answers, that means that you're going to end up with two rational solutions. Again, a rational number is a number that can be written as a fraction. And that is because when you go to take the square root, you are going to be able to take it. It'll be the square root of, let's say, 64, which is exactly 8, or the square root of 100, which is exactly 10. If you end up with a positive answer and that number that you end up with is a perfect square, then that means that you're going to have two real rational solutions. If instead we end up with a positive number, but that number is not a perfect square. So what numbers are not perfect squares? Every other number other than 1, 4, 9, 16. So for example, 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, and so on. If you end up with any of those numbers that are not perfect squares, then you're going to end up with two real irrational solutions. An irrational number is a decimal that continues forever. Okay, the square root of 2, the square root of 3. If you put them in a calculator, of course, the calculator is going to run out of space. But if you were to be able to see this on a computer or something that will give you like hundreds of decimal values, you will see that the number continues forever. What else can happen with my discriminant? Well, it could very well be that it is a number less than 0. A number less than 0, those are negative numbers. If you get a negative number as a discriminant, that means that inside of this radical, you're going to end up with the square root of a negative number. And we all know that the square root of a negative number is going to be an imaginary or complex number. So that means that if you end up with a discriminant that is negative, you will have two complex solutions. This chart is something that you literally have to commit to memory as you continue with these problems. If the discriminant equals 0, that means there's one double root. It is a real rational solution. If the discriminant is a positive number that is a perfect square, that means you have two real rational solutions. If it is a positive number that is not a perfect square, you have two irrational solutions. And if the number comes out to be negative, then you know that you're going to end up with two complex solutions. So let's go ahead and look at some of these examples. Use the discriminant to find the nature of the solutions of the following quadratic equation. X squared plus 4x plus 4 equals 0. This is written in standard form. Standard form of a quadratic equation is ax squared plus bx plus c equals 0. Because it is written in standard form, I know the value of a is 1, the value of b is 4, the value of c is 4. Remember, there's no number in front of the x squared, so the number has to be 1. I am ready now to find the discriminant. The discriminant is b squared minus 4ac. So I'm going to substitute. B is 4 squared, minus 4 times a is 1, times c, which is 4. So I get 16 minus 4 times 1 times 4 is 16. 16 minus 16 is 0. This means that I have one real rational solution or root. Those words are used interchangeably in talking about quadratics. And I consider this a double root. Let's try another one. Use the discriminant to find the nature of the solutions of the following quadratic equation. Again, this is written in standard form, which is awesome. So a is equal to 8, b is equal to 14, c is equal to 3. The discriminant is just b squared minus 4ac. Go ahead and let's substitute. B is 14 squared minus 4 times 8 times 3. 14 squared is 196 minus 4 times 8 is 32. 32 times 3 is going to give me 96. So 196 minus 96 is equal to 100. 100 is a positive number and it is a perfect square. So I'm going to have two real rational solutions for this quadratic equation. Go ahead and pause the video and try this one on your own. A is equal to 3, B equals negative 10, C equals 15. We have to find the discriminant, B squared minus 4AC. B is negative 10 squared. Be very careful with putting negative 10 squared in your calculator. Depending on the calculator you're working with, make sure it doesn't give you a negative 100. A negative number squared is always positive. On some calculators, when you put negative 10 squared, the calculator is quote unquote too smart. And so it's going to go ahead and square the number first and then multiply by a negative. Anyways, just make sure that negative 10 squared is positive 100. So then you have minus 4 times a, which is 3, times c, which is 15. So we have positive 100. 4 times 3 times 15 is going to give us negative 180. If I subtract, I get negative 80. Because I have a negative answer, that means that I'm going to have two complex solutions as the answers for this quadratic equation. Last but not least, if I take a look at this final problem, I do have something else that I had to take care of, which is the fact that it is not written in standard form. So be very careful. You cannot say A is 6, B is negative 1, and C is positive 2. First, you need to rewrite this problem in standard form. So I'm going to rewrite this as 6x squared minus x minus 2 is equal to 0. This means that A is equal to 6, B is equal to negative 1, and C is equal to negative 2. So be very careful. In finding the discriminant, b squared minus 4ac, let's go ahead and substitute. We have negative 1 squared minus 4 times 6 times negative 2. Negative 1 squared is a positive 1. Negative 4 times 6 is negative 24. Times the negative 2 is a positive 48. Therefore, we end up with positive 49. 49 is a positive number and it is a perfect square. Therefore, I have two real rational solutions for this quadratic equation. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.